Hey everyone! In this video I want to show you how to use async await in SwiftUI. This new language feature is available in the development branch of the Swift compiler, and today I'm going to show you how to download it, install it in Xcode, and start using it in your SwiftUI apps. Now, I should warn you that this is an experimental feature, so you can't use it in production apps. You can't even install apps built using this development version onto your physical devices, but we can still experiment with it, play around, and get to know how this feature works because it is coming to one of the next versions of Swift. Sounds good? So let's get started. So let's imagine we're working on an app that allows users to collect articles from around the web. And when they find an interesting article, they can add it to the app, like so. And the app will then download the article and analyze it for you. It will extract the title and hero image and perform some natural language processing to classify the article using tags. Some of these operations are asynchronous, which means they don't finish immediately, so we'll have to wait for them, right? Or maybe not. Maybe that's not a good idea because that will basically mean that your UI freezes. And I think you've used asynchronous code before, and as iOS developers, we're used to using delegates, for example, or callbacks. And in this code snippet here, we've got a method named fetchArticle, which downloads an article from the web and returns the HTML in this trailing closure. And this looks simple, right? But it can easily get more complicated. So let me show you what we jokingly call the pyramid of doom. This is a lot of code here, and it's pretty difficult to see what's going on. So let me walk you through it. So we first fetch the article and wait for the result to come in. We'll have to analyze the result and check if the call threw an error. If not, we can go on and call the next method for extracting the title. Then we can extract the text from the HTML body, then extract the image. Next, we call infer tags to perform our natural language processing, and only at the very top of the pyramid, when we've got all the pieces of information, we'll be able to construct the article and return it to the caller by using the completion handler. I think you will agree with me that this is pretty difficult to read. But the good news is that the Swift team has been working on bringing async await to the Swift language, and this will make your code a lot easier to read. To use this feature, we will need to download the experimental version of the compiler first and install it into Xcode. So let's go to the Swift website and download the experimental compiler toolchain. Scroll down to the snapshot section and then tap here on Xcode to download the toolchain. Don't worry, this is not going to download an entire copy of Xcode, it's just the compiler toolchain. I don't know why they labeled it as Xcode, but it's really just the compiler toolchain. Once this has finished downloading, we can install the toolchain. After the installation has finished, you need to activate the toolchain in Xcode settings. Go to Components, Toolchains, and there you will see all the toolchains that are installed on your machine. So I've been playing around with this quite a bit already. That's why we've got so many of the toolchains here. So let's select this toolchain, which I've just installed. And you will notice that Xcode displays a little blue chain up here in the status area to indicate you're using a non-default toolchain. Keep in mind that you can't use the experimental compiler to deploy applications to the App Store, and you can't even install them onto physical devices. So remember to switch back to the default toolchain once you're finished playing around. Let's first look at the protocol I've used to implement the callback-based article analyzer. So here are all the methods that we called before to download the article and analyze it. So let's take these and then paste them into this other protocol over here that I've prepared for our asynchronous article analyzer, and then rewrite it so it no longer uses callbacks. To do this, let's remove all the completion blocks and use async await instead. So we need to tell the compiler this is an async method that might throw errors, and the return type is a string. Now let's do this for all the other methods as well. Down here, we return an array of tags, so the return type will be array of tag, like this. Now, this looks a lot simpler already, and it's so much easier to read, I think. So let's now rewrite the code that controls the whole process. And again, let's copy this code and paste it into this method here, and then start rewriting it. Let me first remove the completion block and tell the compiler that this is an async method. So async throws, and the return type is an article. Now let's throw away all the code we don't need and keep just the methods we want to call for reference. First, let's fetch the HTML text. So the method we're calling is asynchronous, and it might throw, so we need to call it using try await fetch article from URL. Next, let's get the text. Try await extract text from HTML text. Next, let title extract title from HTML. Let image URL equals try await extract image. And finally, let tags equals try await self.infer tags from text. This will read the text. Oh, and let me fix this compiler error here. Now let's take this call to construct the article. And then instead of using a callback, we can just return this article. Let me clean up the code a bit. Get rid of all of this. And this is our protocol and our implementation, and it looks so much cleaner already. So the next step is to rewrite the code that actually downloads the article and analyzes it. So here is our current implementation. So I'm going to copy all of this code piece by piece and rewrite it to make use of async await. Let me make some space here. All right, so here we are. And Xcode is helpful and offers to generate the method stubs for our protocol. Yes, please. I like IDEs that are helpful. Now we can copy this chunk of code here and insert it over here. We don't have a completion handler anymore. And up here we can just throw an error like this. The rest of the code needs to be wrapped in an asynchronous context. Async await comes with a couple of helper methods that make this easy, and the one that we want to use is with unsafe throwing continuation. This function accepts a closure that takes one parameter. Let's call it continuation. Now let's take all of this code here and move it into the closure. Now, we eventually want to return the result of this continuation. So let's say return try. And of course, we don't have a completion handler anymore, so we need to replace this with a call to our continuation. And in the code completion, we can see that there are a couple of options here. We can return a result or throw an error. And that's what we want. So resume throwing using analyzer error.download failed. Down here, we can use the continuation to return the HTML texts. Remove the call to the completion handler. So the compiler tells us that this is an asynchronous call, and it even offers some help. So let's apply this quick fix here. Nice. Sweet, so let me quickly implement all the other methods too. Cool, so let's close this editor and go into this article view model. It contains a list of articles up there, and the UI calls the add new article method to trigger fetching a new article whenever the user adds one. So we still use the old callback-driven analyzer service, but we want to use the new async analyzer service. So let's turn off this call and then copy this code here. Instead of using the analyzer service, let's use the async analyzer service. So async analyzer service dot process URL. This method returns an article, so let's assign this to a new local variable, try await. Now, when we're assigning this to the articles array, we need to make sure that we're on the main dispatch queue because this will trigger a UI update. So let me take this chunk of code here. This adds the article to the array of articles. And since this function might throw an error, we need to write some error handling code. Do catch and print the error. Very creative, right? Let's remove this piece of code here. And because this is asynchronous, we need to put this into an asynchronous context. The easiest way to do this is to use an async handler like this. And finally, let's make sure to update the progress spinner on the main queue. So dispatch queue main async, and down here as well. And we can remove this. So let's run the application again. Let's analyze the article that goes with this video. And here are the tags. So it works just like before. Nice. So let's take a final look at the protocol and the process implementation. So what I really like about this, we've got a much cleaner API surface. It's easier to see what the input parameters are and what's the return type. Also, the method signature now explicitly tells us that this is an asynchronous method, and the call side is a lot cleaner as well. So no more nested callbacks, no more pyramid of doom. So I think async await is a great addition to the Swift language, and it will make writing your asynchronous code so much easier. And it's also a great tool for API developers out there because it enables you to explicitly state that certain methods and functions are asynchronous, and the compiler will warn your API users if they're using the API calls in the incorrect way. For example, if they don't try await when calling your code. So this is really, really cool. So are you excited about this feature as well? Are you thinking about adding it to your own applications once it becomes available in the next version of Swift? Let me know in the comments. Thanks for watching, and I will see you in the next one.